Chinese Academy of Forestry in Beijing, China. And this work has been done together with some of my colleagues in the academy and also Dr. Tseng from the University of America. This map shows the forest distribution of China. Yeah. So we are, in this presentation, we are targeting to study this area, which is in the northeast part of China. It's also one of the two main forest areas of China. You can see northeast and south of China. In fact, this campaign, the Daxing campaign, just look at this area, just south to Russia, Siberia, and east to Mongolia. This is the left first I will introduce the forest resources and the national forest inventory in China, give some background information for my project. Then introduce the experimental design and the data collection for my study. Then to do the forest background biomass estimation using this large-scale fusion. This is for the forest resources in China, according to the seventh National Forest Inventory during the 2004 and 2008. That is almost 200 million hectares of forest coverage, about 20% total of the land area. And also for the plantation area, it's also very huge, almost 62 million. I mean, it's almost 1/3 of the total forest plantations. And also now we are almost finished the 8th National Forest Inventory, which will be finished and the report will be published this year. Also for the National Forest Inventory, it's based on the systematically sampling plots. So this system has been built in the 1970s. It's mainly focused on the volume density, the productivity of the forest. But now it also moves some new factors to include the more ecological effects like carbon sink capacity. And this is what the permanent forest looks like. It's like every 2 by 2 kilometers or 8 by 8 kilometers. Overall, the country we have 415,000 plots. All of these are permanent plots, have been measured for a couple of times, and all of this data have been used to estimate the forest, total forest volume, forest coverage. And also since the 1990s, we try to include more remote sensing data to get better estimation of the forest coverage. And now it's almost 3 million remote sensing plots. We also get the screening interpretation of the remote sensing data to get forest and non-forest. But all of these are focused more on the forest coverage and the forest volume density. So now the forest coverage in China is increasing, but still there's some area and forest degradation. So now we want to evaluate and monitor the forest more quantitatively. That's why we are trying to use the new focus on the biomass and carbon estimation. This is an ongoing project. In fact, during the past, we are focused from the field measurements, especially the permanent plot system, and then to estimate the biomass. This is only give us statistician number. There's no map products. And we are also trying to use this airborne LiDAR data. Because this from the field plots, we only get some discrete plots data estimation. And now we are trying to use the airborne LiDAR to fly some strip samplings and then to do the estimation. But again, it's still only the statistician numbers, no continuous map. And also we try to use the spectral LiDAR, acid glass data. And also, this also only gives us a discrete estimations of the total biomass. So now for the thinking is we can have all of these different data sources from the in-situ measurement for airborne and also from spaceborne. Whether we can fusing them together and then to get a better estimation of the biomass. This is the target. But all of these three data are still not a full coverage, still need some samplings at the point scale or the plot or the strip scale. So now we try to fuse it together with the imagery remote sensing data with this specially distributed temperature biomass estimations. Then we can get a continuous biomass dimension map. And from this map, for sure, we also can get a total biomass and then can get the compare to the result. But again, it's still an ongoing project. Now this project has been done together with the National Forest Inventory groups and also our remote sensing teams. Now, here we just try to, in this presentation, try to communicate report to you the first results of all these studies. But this is still an ongoing project. Yeah, this is the campaign we have carried out last year. In the last summer, this is the northeast of China, Daxiang. Here we can see for the scripts. In fact, all of these scripts have been covered by the airborne LiDAR data. But when we designed these airborne LiDAR flight lines, we considered the distribution of the spaceborne LiDAR strips. You can see these strips are the spaceborne LiDAR orbits. Over this data, we also have the spaceborne LiDAR. And also for these dots in the light green, so these are the permanent plots of the National Forest Inventory plots. All of this data we also covered by the airborne LiDAR, and we also have two areas of the small area. It's for the forest research stations. We also have some small areas coverage. This is all. And also during the flight, we do the simultaneous fieldwork collection. We get the 80 field plots to measure the deviation of height and species for the biomass. And then from the field data, we can build a model from the field measurement biomass and to the airborne LiDAR. Here is the model for the needle forest and broadleaf forest and mixed forest. And also we can put all of these three forest types together. We can see that from the airborne LiDAR data, it can give us a pretty good estimation for the biomass. And also, after we get the model, we can use the model to all the airborne LiDAR data covered areas. Actually, for each strip line, for each flight line, we can get the map from the airborne LiDAR for the height and about on biomass. And here you can see for all the data. For the data we collect for it's over almost 4,000 square kilometers. This is from the forest research station here. The forest research station here. You can see that you have a better forest background biomass levels. You can see that this is the height and this is the background biomass mapping. And after we got this information, we also can train this the estimation from airborne LiDAR data to the spaceborne to acid glass data. So for all the acid glass data, for all the footprints, we can have the biomass, we can have the height and the biomass estimation all of this data. Now we're trying to fill all of this data together to a imagery data. Then we can get a continuous biomass distribution map with the estimations. But for this kind of map, yes, for overall, it have a good spatial distribution. So in fact, this area they have several big forest fires. This area has a forest fire in 1987. This area is 2006. So we can see that still have the low biomass level. And also for the forest, this area is still in the natural status, which have the high biomass level. But now we are still working to use some other data sources to evaluate this map. But because we also fly the area, the forest restriction areas here, which I showed you in the previous slide. And for this small area, we also have the biomass information from the airborne LiDAR directly. So for this area, we also can get a compare for these two areas. Yes, for the difference is only 8% almost. So it's overall it's in a good accuracy. So for the brief summary is this is for the regional forest biomass was estimated by combining with the field measurements, airborne LiDAR, spaceborne LiDAR, and also the optical remote sensing data. When we do the we use the products from Maris and Modis products. Now, so the result of the study is encouraging. It's isolated mass also can estimate successfully in a regional scale for the biomass. And for the next work, we will try to investigate this method to the other sites of temporary forest in China. Also, the first inventory plus data will be used to training the airborne LiDAR data. Because now we are training with our field measurements. Next, we try to use the plus for the training. And then now we are using, for the mapping, we use the Maris and the Modis products. For the next, we try to use some mid-resolution with the X level products. Also, for the biomass estimation, this can be with compared with other inventory-based estimation. Here we are targeting to use the estimation from the polygons and some compound levels. Okay, that's for my presentation. And as a short announcement, we will host the Silver Data of 2013, which is focused on the LiDAR application in the forest ecosystems. This event will be held this October in Beijing. And yes, thank you for my presentation and welcome to the Silver Data conference.
Okay, thanks for your presentation. I think it's a very good job. The first question, actually you developed 3 models for estimating the AGB, right? So the one for the forest, I mean, can you tell me how to define the mixed forest?
Mixed forest?
Yeah, can you give a definition?
Yeah, we use this definition from the forest inventory in China. The mixed forest means there's each forest type have over 60%. I mean, non-broadleaf or the leaf about the 60%, and then we call it mixed.
So it's inventory data, right?
Yeah, it's inventory. And also when we do the field work, we also follow this definition.
Okay. And second, we know you combine the many data together in the plot data and the space bound and the L bound, right? And the IS image. Actually, I'm still not very clear about how to fuse this data with a different scale, the resolution.
Yeah, it also confuse us sometimes. Yeah, thank you for the question. And yeah, if for the field data and if we do the scaling in 2 ways. The first way we training the field measurements data to the airborne LiDAR, and then from the airborne LiDAR to the spaceborne. This is the kind of 3 stages estimation and the training. But because we also have this permanent plots, in fact, this area is about 3,000 permanent plots. So we also have a good spatial distribution. So when we train this continuous map, we combine and use this data and this spatial line data. And also we have flight these strips from airborne LiDAR. So we just combine all of these together. It's like to get more training samples than to get better training. And also when we build the model, estimation models, we try to include some others like ecoregions and build the model to kind of use some of the local training data sets when we do the machine display.
Okay, maybe we can talk about later. Actually, I'm not very clear. So the time for the others. Okay, thank you.
Thanks for your presentation. I've got a follow-up question to my colleague. How did you actually do the stratification of the 3 forest types? I mean, he asked about the definition, but how at the end did you stratify spatially, and then at the second step you applied your different biomass functions? And which error is attached to the stratification? I mean, I at least believe that is a quite crucial step in your method.
Yeah, if it in the introduce this, for the airborne LiDAR estimation, we have tried to separate these different forest types and also combine them all. So even combine them all, still give us a pretty good estimation. So when we build a model for the airborne LiDAR data, we just use for all the forests. We don't use the forest types. But when we train the model for the continuous map, we try to build the model for different forest types. That means maybe for the broadleaf and the needleleaf, maybe they use some different.
But that's clear. But then, how do you know which formula apply for which pixel? Was it like vegetation continuous field, or which kind of product did you use for the stratification? I mean, the spatial stratification before you applied those.
Okay, for the spatial, we use the products from the MODIS classification maps and also the global cover maps. You can combine those two to get the spatial forest types information.
And have you done an accuracy assessment? I'm just curious. Have you done like a validation on how good the stratification is?
No, we did not come to that yet. Even now we are doing our own classifications, which based on the HGS-CCD images. Yeah, for that data we will do the accuracy validation.
Okay. Thank you very much.